In this lesson, we're going to talk about families of quadratic functions. A family of quadratic functions is a group of parabolas that all share a common characteristic. And the algebraic model of a quadratic function can be determined algebraically. If the zeros are known, then we can write it in factored form, leaving the variable a unknown, and then we can substitute in another known point and solve for the variable a. If the vertex is unknown, then we can write the quadratic function in vertex form, again leaving the variable a unknown, and then we substitute in another known point and solve for the variable a. So if you know the x-intercepts, put it in factored form, sub in a point, solve for a. If you know the vertex, put it in vertex form, sub in a point, solve for a. Alright, so let's do this example. Determine the equation of a parabola with x-intercepts at -5 and 1 that passes through the point 3, -32. Now, if a parabola has a vertex at -5, then we know that one of the factors will be x minus -5. And if a parabola has an x-intercept at 1, we know one of the factors will be x minus 1. Well, x minus -5 can be rewritten as x plus 5, and x minus 1 stays as it is. And we have to put an unknown factor in front, and we call that a. Now what we're going to do is sub in the point 3, -32. That means we have to let x equal 3, and we have to let y equal -32. So we take -32, plug it in for y, 3 goes in for x. 3 plus 5 is 8, 3 minus 1 is -2. So -32 is equal to a times -16. And dividing both sides by -16, we get a equaling 2. So the equation of a parabola with x-intercepts at -5 and 1 passing through 3, -32 is y equals 2, bracket x plus 5, bracket x minus 1. Now, that was a situation where we knew the x-intercepts. What if we know the vertex? Well, in this case, we can say the vertex is 227. That means the parabola will have the form a x minus 2 squared plus 27. When the vertex is 227, this is how you can write it. But we don't know that multiplicative factor in front, that a value yet. But thankfully, we know another point on the parabola, the point 572. So we let x equal 5, y equals 72, and we plug that in. 72 for y, 5 for x. 5 minus 2 is 3. Subtract 27 from both sides. So we can say 45 is equal to a times 3 squared. 45 is equal to 9a, which means a is 5. So instead of saying a times x minus 2 squared plus 27, we can say 5 times x minus 2 squared plus 27. Now in this question, we're going to use irrational numbers. Suppose we have a parabola with zeros at 4 minus root 5 and 4 plus root 5, and the parabola extends through the point 5, -2. They want us to determine an equation in standard form. This is the first time the question tells us a specific form to put the equation in. So, if one of the zeros is 4 minus root 5, then one of the factors will be x minus 4 minus root 5. If one of the zeros is 4 plus root 5, then one of the factors will be x minus 4 plus root 5. And we still have that multiplying a in front. Well, we distribute the minus sign in here, that gives us x minus 4 plus root 5. Distribute the minus sign here, that gives us x minus 4 minus root 5. And we still have the a in front. And now what we're going to do is distribute. x times x is x squared. -4 times x is -4x. X times x is x squared. X times -4 is -4x. X times -root 5 is -root 5x. -4 times x is -4x. -4 times -4 is +16. -4 times -root 5 is +4 root 5. Positive root 5 times x is positive root 5x. Positive root 5 times -4 is -4 root 5. And positive root 5 times negative root 5 is negative root 25. Now, as we collect like terms, we can see that the positive 4 root 5 and negative 4 root 5 cancel each other out. The negative root 5x and positive root 5x cancel each other out. So we have x squared minus 4x, which is minus 8x, plus 16, and then we have minus root 25, but the root 25 is just 5, so it's minus 5. And we can collect these terms up, and we see that we get x squared minus 8x plus 11 in the bracket. Now we can sub in an x value of 5 and a y value of negative 2. And now, when we do that, we let y be negative 2, we let x be 5, and we plug in our values. We still have the a in front. Well, 5 squared is 25, negative 40, positive 11. These numbers add up to negative 4. So negative 2 ends up equaling a times negative 4, or in other words, negative 4a. Dividing both sides by negative 4, we get a equals a half. So now we can go back to this line right here, and we can say y is equal to 1/2 times x squared minus 8x plus 11. And when we distribute that 1/2 in, because the question wants it in standard form, and when we do that, we get 1/2 x squared minus 4x plus 11 over 2. And now we'll do a word problem. In this word problem, we have a tunnel with a parabolic arch. The arch is 12 meters wide, and the height of the arch 4 meters in from the left edge is 8.8 meters. And we want to know if a truck that's 2 meters wide and 10 meters high can safely pass through that arch. So we see here we're going to have a truck going through. The truck might look like this as we look at it from behind. This is the point 0, 0 and the point 12, 0 because the arch is 12 meters wide. And so we can say in factored form that the equation of our parabola is a times x minus 0 times x minus 12. X minus 0 simplifies to x, so we have ax times x minus 12. Now, we know the height of the arch 4 meters in from the left side is 8.8. So that's like saying right about here is a point 4, 8.8. 4 meters in from the left and 8.8 meters high. Okay? So we know one of the points on this parabola will be 4, 8.8. So we sub that in. This was the equation we had a moment ago. We let y be 8.8, and we let x be 4. And we get 8.8 equaling negative 32a, which means 8.8 over negative 32 is a. And when we do a little simplifying, we get a is negative 11 over 40. So the equation of the parabola representing the bridge is negative y equals negative 11/40 x times x minus 12. We still haven't answered whether the truck can fit through. So this we have to think about. Imagine the truck is heading towards a parabolic arch and it's not sure if it's going to fit through. It's obviously, in that case, going to aim for the middle. Now remember, this is an x value of 0 and this is an x value of 12. That means the axis of symmetry will be at an x value of 6. Okay? Now the bridge is, the truck is 2 meters wide, so there will be 1 meter on this side and 1 meter on this side. 1 meter to the left of 6 is 5. 1 meter to the right of 6 is 7. So these are x values. Now think about it. If you're a truck going through, the first place where you might have a problem would be at one of these corners. This is where you're really interested. If the corners fit through, then the middle of the truck will definitely fit through. But the first place where you could have a problem and not being able to fit through would be at those corners. So you're hoping that at x equals 5 or x equals 7, the bridge will be high enough to accommodate the truck. Now hopefully you remember that parabolas are symmetric, which means since 6 is the axis of symmetry, at an x value of 5 or 7, the bridge is equally high. So we can choose either of those numbers as our testing point. So imagine the truck heading towards a parabolic arch. The truck will aim at the middle. The axis of symmetry is at x equals 6, and it is 2 meters wide, meaning that there will be 1 meter on either side of the AOS, the axis of symmetry. When I say it is 2 meters wide, I mean the truck. The extreme left of the truck will be at x equals 5, and the right of the truck will be at x equals 7. If there's a problem with the truck fitting through, the problem will be at one of these two x values before there's a problem at x equals 6. Therefore, we need to determine the height of the bridge when x equals 5 or x equals 7. It's the same height at either of those because they're equidistant from the axis of symmetry. Okay, that has to do with the symmetry of a parabola. So we need to determine the height of the bridge when x is 5 or x equals 7, and then we need to hope, for the driver's sake, that the height at x equals 5 or x equals 7 is at least 10. Okay, because we know the truck is 10 meters high, we hope the bridge is 10 meters high. So here's the height of the bridge. Y is a negative 11/40 x times x minus 12. We'll let x equal 5. We could have just as easily let x equal 7. When I plug a 5 in for x, I get that the y, which is the height of the bridge, ends up equaling negative 11/40 times 5 minus 12. That's 385 over 40. That's about, like, it's a little bit greater than 9.6, but it's not 10. It's actually less than 10. What that means is, at those points, the height of the bridge is less than 10, but the height of the truck is 10. So since the height of the bridge is less than 10, the truck cannot safely fit under the bridge.